Go ahead, I'm going to record this too, so if you need to go back and refer, okay? All right, what I want to kind of do through it, and I want to spend about 15 minutes on this so you can kind of get this going and everything. So the first thing is you really have three graphs, and then I'll kind of talk about what you're ultimately doing. I want to kind of start you and tell you what to look for on these three graphs. Okay, this graph number one is the easiest. All that's doing is that's doing the motion of the pendulum. Okay, so you know that, right? The motion of the pendulum, if you read the problem, okay, it starts there. That's called the equilibrium position, okay? And then it's going to go, and I can't remember if this says if it swings to the left or swings to the right. I think it's supposed to swing to the right because I'm wanting a sine wave to come out at a certain point, okay? So what it's going to do is it's going to do that, okay? And that will be like your second point in the cycle. Then what does it do? Then it goes back to equilibrium. That's point number 3. Then it swings over here. That's point number 4 and point number 5. So it's going 1, 2, 3, 4, 5. That is one cycle, okay? If you read the problem, it does say this. It says that 5 swing cycles are 4.6 seconds. So I'm going to write that down. You can write this down on scratch paper if you want to, because I kind of guide you through a lot on this problem, because it's not a real easy problem. So 5 cycles, 4.6 seconds. You need to be able to figure out what one cycle is. Well, tell me what you do to figure out one cycle. That's an equation, right? It says 5 cycles of 4.6. So what would one cycle be? Just divide by 5, right? Okay, let's go ahead and do that. I want to get that out of the way. Okay, so you would get one cycle is going to take, and that on the calculator, what is that, 0.9, is that 0.92? Okay, thank you. Okay, that's an important part of the problem, all right? Now, all I'm going to do on this one is this first graph is going to show the motion of the pendulum. So you're going to be kind of doing something like this. The only thing that I need you to do is I need you to label everything. So you need to label what that key point is. I'm not going to tell you what it is, but if you read the problem, it tells you, okay? You also need to know what this y value is right there and what that y value is there. That's what you do to get the first graph is that, because all that's doing is that's what's going to come out on your calculator. It's going to swing a certain way, and all these numbers right here, if you read the problem, are there. Okay, does that make sense? Okay, your job is just to fill in the points on that, all right? So that's an easy part of the problem right there. Just your graph's going to look like that, but you need to label what the x values are and those two y values. Read the problem and you'll easily figure that out. Okay, now what I'm going to do is I'm going to start you on the second graph, get you to a point where I can kind of talk through what you're going to do, okay? All right, what's going to happen on this now is, first of all, you're going to get 5 key points. On scratch paper, I would just go ahead and do this, and I'm going to start you off on these 5 key points and tell you what you're going to kind of think about here. This one's the one that's kind of tricky. So what's going to go here is that's going to be time, okay? And remember, we just figured out that one cycle is equal to 0.92 seconds. Okay, that's what we just did. I told you 5 cycles is 4.6, so that's what one cycle is, okay? Now, these are times. So where would you expect the time to start? 0. Where would you expect it to end at your 5 key point? 0.92. Okay, that's one cycle, right? I'm telling you that much. Okay, the rest you're on your own, and it's not that hard. I mean, these things kind of get evenly subdivided, right? Okay, so that's one cycle, okay, is 0.92. Now, this is what's tricky about this problem to students is this. Okay, what goes there is the horizontal, and you want to write this down and make sure that you're real clear on this, is the horizontal distance, okay? So let me go through, let's just get a couple of those, and then you can do the rest, okay? Because I'm going to give you roughly what the graph looks like and talk through what you've learned this semester to get the graph of that wave, okay? So I'm going to draw a pendulum one more time. Okay, let's just do I'm going to do the first 2 points, but that's all I'm going to do. okay? What you're doing is you're measuring how far it is this way. If you read the problem, it says that the horizontal distance, the horizontal distance from equilibrium to highest point is 4.5. So what it's going to do is this first point, its horizontal distance is 0, right? Because it hasn't moved yet. I'm talking about the distance in the x direction, okay? Now what the problem said is it said it swings to the right, okay? So according to the problem, how far does it swing to the right? It says 4.5, right? So your next point would be 4.5. Now I'm not going to tell you anything else. I've already told you a lot as it is. Your job is to figure out the rest. So what's happening is you have, at 0 seconds, you haven't moved. At whatever seconds, you moved 4.5. Then where's it going to go back to? Back there, and then what's it going to do? Swing this way and back to the beginning. So your job is to finish up those points. Okay, does that make some sense? Okay, I've already kind of done a lot for you, but at least I'm helping you kind of think through this. You haven't done parametric equations in trig, so that's part of the reason I go over this a little bit more in class. So that's the idea. Okay, so you'll be filling in those points. That's essentially what you're doing when you're answering these questions. Now, I'm going to go to the next page, and I'm going to give you a rough idea of what these points are doing. I already told you you have 0, 0, and I told you you have something and 4.5. Okay, so I'm just going to kind of give you an idea of what goes on in this. You got these 5 key points. We did say the last point was 0.92 something, but that's all I filled out for you. Okay, so what you're going to do is you're going to plot these points. Well, you're going to have a t-axis for time, and then this is really going to be the horizontal distance, like this. Okay, now what I'm going to do is you're going to end up with either something that looks like a sine wave or a cosine wave. Okay, so what you're going to end up having is this is going to go out to 0.92, and then you're going to divide that up into 5 equal points, so you'll have 5 key points. Okay, now I'm not going to give you those points specifically, but I'm going to tell you what you will get if you do this right. Okay, what will happen is you got 0, 0, and it's basically going to do something kind of like this. Okay, if you fill in your points correctly, you're going to have something that goes like that. You just need to be sure that you label, you know, what the y values and everything is there, and it's not that hard to do. Okay, now does that look more like a sine wave or a cosine wave to you? Sine wave, because it starts at 0, 0. So let me explain what you're going to do on this then. You're going to, the general formula, but we're going to say x of t, because this is giving the horizontal distance. So the general formula that you learned for a sine or cosine is a sine of omega, and then it won't be x minus something, it'll be t minus something, because we're talking about time, minus phi plus b or something like that. On the test that I gave back tonight, you had one problem where I gave you a graph and you gave me a cosine. Okay, so what your job is, and I'm not going to go over this part because you got to figure this out, that's the amplitude. From that graph, you will figure out what the amplitude is. That's pretty easy. The amplitude is 1/2 the distance from the max to the min. You can do that in your head, or you can do that formula. Okay. You do have a period change. That's pretty obvious. Now, that's one period, right? Because that's one cycle. You're going from 0 to 0.92 seconds. So you're going to know that the period is equal to 0.92, right? What is the general formula that we use for the period on a sine wave or a cosine? What have we been doing? 2 pi over omega, right? Okay. So what your job is from there is to figure out what omega is. Okay, you have done that before. You did that on the last test. So you need to figure out A and omega. Okay, what is phi in this formula? What does that mean? Ends with P, phase shift, right. Does it look like this as a phase shift? Because it's a sine wave. Where does the basic sine start? 0, 0. It doesn't look like it has one. Okay, up, down. Okay, you got to figure out if it has one or not. That's your job. So what you do on this part, this is half of the problem right here. You need to figure out what this is, and then in your calculator, in parametric mode, I'll show you how to set that up in just a minute, that's what you would have for x of t. Okay, so you're going to have, you just need to figure out what those points are and what that graph is, then figure the equation out. You have the power to do that. You've done that kind of work this semester in graphing. You guys see what I'm getting at with that? Okay, figure out all those numbers, and then you'll have that okay. Now what I'm going to do next is I'm going to go on to the third graph to kind of get you how this goes. Okay, so you're just kind of answering the question, so you'll be able to do that if you do your graph correctly. Now what we're going to do on the vertical position is this. Let's kind of think through the 5 key points on this. And this will help you if you guys are going through the calculus sequence. If you take Calc 2, you'll learn more about what a parametric equation is. And what it is you have an equation that represents the x value, the horizontal distance, and one that does the vertical. Okay? So let's just kind of talk through a couple of these points. Then I'll give you kind of an idea of how this goes. Okay? All right, so first of all, time is going to go there. Okay? And what's going to go here is, and this is a good thing to write down, or you can watch the video. I'll post this after class. So this would be the vertical distance. So we're talking about where is the pendulum this way and this direction. Okay? Well, okay, first of all, what you want to do, let's look at how the pendulum swings. Okay, first of all, in your first point, you're going to have a time of 0 again, right? Okay, now if you read the problem, I tell you how high that pendulum is from the ground. It's there. Read the problem, it'll tell you what that is. Okay, so right now at 0, that's going to be whatever that beginning vertical distance is. Read the problem and that'll tell you. Okay, that's where it is on the y-axis. Okay, it says it's a certain distance above the ground if you read that. Okay, that's what that is. Okay, then what it's going to do is the second point, which you'll have to figure out. Okay, the pendulum is going to swing to the right and get there. What you need to do there is you need to put what the height is. Okay, that will be the height of the pendulum when you do that then. Okay, so this is going to be the beginning height right there. That's going to be the total height. Does that make sense what I'm doing there? Tell me. Okay, you're looking at the y value on that pendulum. Okay, now where does it go? In the third thing, it goes back to here. So it would be back to whatever this is. So on this and this should be the same. So it's just going back there. Okay, then what's it going to do? It's going to swing this way. So you're going to have another time, and then you're going to have that same height. Like that. You're talking about height as your y value like that. Then it swings back to the beginning, and it's going to be back to that same y value right there. Okay? Again, a cycle goes from 0 to 0.92 seconds like that. So I'll give you that much information. So when you're doing that, just think about how the pendulum goes. 0 seconds, you're at that height, right? You see what I mean? It's however high it is above the ground. That's in the problem if you read it. 0.2. You're at that height, so that's what you record. 0.3, you're back to that height. 0.4, you're to that height, and 0.5, you're back there. Tell me if that makes sense. Yes?
No.
You okay?
Yeah.
Okay, everybody else, you got something?
So the time for the first point is 0. Would that be the same for 3 and 5 as well, or no?
Well, this first point would be just when you begin, and it would be how high the pendulum is from the ground at the beginning. If you read the first page, I think it tells you the pendulum is a certain height above the ground. So that's what goes there. And then what it's going to do is swing to the right. I also tell you what that height is. You get all that information from page 1.
I was mistaking time for that.
Yeah, time is your x value.
Yeah.
In this third graph, your y value is the height of the pendulum. Okay, like that. Tell me if that makes sense. Okay, so you get those 5 points. Now what you're going to do, I'll kind of give you an idea of how this graph goes. I'm only going to do this roughly, okay? All right, so what you're going to end up having on this, if you do this correctly, after you do your points, you'll be able to check this. I'll tell you kind of what you'll end up having, okay? I'm not going to tell you why. You'll figure that out when you get your points. So you'll have something that looks like that. What you need to do, obviously, is label everything. Everything needs to be labeled. So that's kind of the key. Okay, label your key y values and your key x values like that. And then on this one, you can either do a sine or you can do a cosine. It's your call. What I usually tell students to do as a cosine because it starts at there's your high point right there. Now, if you do a sine, I don't care. It'll still work. So what you're going to do, if you decide to do a cosine, you'll have a cosine of omega, and then it would be t minus phi plus b. You got to figure out the rest. So what you're going to need to figure out there is the amplitude. What you got to figure out there, remember the period is 2 pi over omega. You're going to know what the period is if you look at that graph correctly, okay? And if you look at the graph I drew there, does that look like just one cycle or does it look like 2 cycles? Tell me. That looks like 2 cycles, doesn't it? Okay? Because it goes like this, then it repeats itself again. Okay, like that. So actually what's going to happen is your key points are going to kind of go like this. 1, 2, 3, 4, 5. That's going to be one cycle. Then it repeats itself again. So you might make a note of that. Okay? Does this thing look like it has a phase shift? If you're doing a cosine, did that phase shift? Yes. Where does the cosine start? Usually at 0, 1, right? So does it look like that phase shifted? Looks like it phase shifted to the right, so you need to figure that out. Okay? Does it look like it moved up? Yep. Okay, so you got to figure out how far that thing moved up. So that's the big work of the problem, is you got to figure all that out. Okay? I'm only kind of telling you what you're going to get on the graph, just kind of for checking purposes, so you think through the problem correctly. Okay, does that make sense? Okay, so I've kind of got the structure of the 3 graphs. Then what you're going to do to put this all together, now on my calculator, I'm going to show you basically what you would do. Okay, just give you a rough idea. I've already did this, but when you put this in, but I'll record this so you can rewatch this if you feel like you need to. So you'd have mode, and then you would have to go, you want to be in radian mode. That's important because all the angles are in degrees. Then you move over to parametric mode like that. So you haven't done this semester. I like to do this problem because it introduces you to this idea of a parametric equation. Okay, so what you're going to do is in x1t, what that's going to be is that's going to be the second graph. That's going to be whatever you have for graph number 2. So that's going to be the sine of something, okay? That's your job on the second graph. When you do, and what that's doing is that's doing the horizontal distance. So I kind of helped you with that a little bit, okay? I'll go back real quick to where I was when I was talking through this. So this second graph, you're going to get an equation for that that's going to be a sine wave. You're going to put that in your calculator for x1. Okay? Then what you're going to do for y1 of t is you're going to put in that third graph. So that's the third graph. That's the one that I just did. That will be this one that you'll probably use a cosine on. Or if you prefer to use a sine, that's fine. I don't care. I just want it to work. Okay? So then that's what you're going to have when you put that in kind of like this. So what I'm going to do is I'm just going to put something in. Okay? And this is wrong, but I'm going to say like we have 2 sine of x. Or it'll be t is what will come out on your calculator now. Okay? So let's put that in. Like that. You can put anything in you want to. I told you guys like last week you can sort of experiment with this to get a feel for it. And let's say the second one's a cosine. Let's say that it's 3, and I'm just making this up. It's 3 cosine of t. Maybe there's a phase shift. I have no idea what it is. Maybe it's shifting up 3. So when you get your 2 answers, you're going to put that in like that. Okay? Now for the window, you got to go back to the first graph on that window. Okay, one thing it said 5 cycles. If you read the first page, I think that was 4.6 seconds, right? That's what it says. So you would go 0 to 4.6, or you can even go to 5 if you want to. Okay, so let's just kind of do that. So you're going to go like that. So we did say that's what a cycle is. That's what t is. Okay, let's do that. For your step, I think I tell you on here somewhere to use something like 0.05. So you want to use that kind of small. Okay? Now for your x-axis, okay, if you read the problem, it said that it swung out to 4.5 feet this way. Then it swung out to 4.5 this way. So you could try something like this. Like maybe -5 to 5, like that. Okay? Scale of whatever. Okay, what is y? Y is the distance the pendulum is from the ground. So you would probably go 0 to whatever. I tell you what that max is. I don't remember what it is, but that's your job to read this and figure that out. Let's just try something like that. Now what'll happen is if you get that put in, you need to figure out a sensible window for your problem. And obviously you're looking for two correct functions. So you got that, you're going to have that set up. You're going to have your window set up. Now I'm going to type graph, and this is not a pendulum. There's no telling what it's going to do, okay? I mean, it may go in crazy in a circle or something like that. So what the other thing that you want to do is you want to set this so it does the ball. And different calculators do this different ways. What I do on mine is I go with the left cursor until I'm blinking on that. And then you just press enter, and you go down to this thing that says line. And then I think what you do on that is you just keep pressing enter until that, whoops, I'm doing the wrong thing. Let me do that one more time, okay? This is how it goes on a TI-85 or 84 plus. Okay, so I press enter, I go down here, okay, and I got to get that kind of going. And then what I do is just kind of toggle through that until I get the ball. One of them is a ball and chain. I don't want that, I want the ball. So you do that. Then you go down to OK and press enter. Okay, now if I try this, let's see what I got. This is probably crazy too because I just made this up. Not a pendulum, that's for sure. Okay, so I just went up for a couple of times and that's not it. But you know what's going to happen, right? It's going to swing perfectly through that and you should be able to count 5 cycles. It should start here, go like that, and do that 5 times. Okay, and that's what you're going to show me. Okay, now what you can do is if it's not working by Thursday and stuff, you know, you can come by my office if you want. You can stay after class, and then I can help you kind of see what's wrong. But that's the key, is you want to get those 2 graphs right there correct. If you get them correct, it'll work the first time. Okay, you see what I mean? Okay, so hopefully that'll help you a little bit. I will post this tonight, so if you do need